Okay, uh, welcome to Sundar's lecture. In this lecture, we are going to see basics of resistors, inductors, and capacitors. Right. Before entering into the topic, I just want to tell you the importance of these three elements. First, I will write down the topics. So, this is lecture number 1, and in this lecture, we are going to see basics of resistors, inductors, and capacitors. Right. So, what is the importance of these three elements in electrical network? If you take any electrical network, all the parameters are transformed into these three elements. If you take anything, any voltage drops or anything else, all the parameters will be reformed into these three elements. So, understanding the basics of these three elements will help you to approach any electrical network. So, in these lectures, we are going to see very basics of these three elements, how they really work, what are they capable of. That's all. That is what we are going to see in these lectures. Right. First, I will take resistors. 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 Right. So, everybody knows what is resistors. Resistors are current limiting elements. It opposes the flow of electrons in the electrical network, right? So, for to explain resistors, I want to draw a circuit. So, a voltage source is connected across the resistor. This is the circuit, right? So, this is resistor R plus minus V. So, my current will flow in this direction. That means from minus to plus. So, this will be I, right? So, I have already told you that resistors are current limiting elements that will limit the current. How it is actually limiting? So, if the resistor is connected across this voltage source, this resistor will take energy from the voltage source, and whatever the energy it is taking from the voltage source, this resistor will dissipate the energy into atmosphere by means of heat. This we know already. This is the uh, purpose of resistors in the electrical networks. So it is actually limiting the current. Now my approach towards resistor is a different one, not like this. I just want to explain the resistor in a different way so that you can easily compare it with inductors and capacitors. Right? So fine, I will come to that point now. You see, this circuit is connected at a particular time. This circuit is connected at a particular time. Now, my question is, what is current at 5 seconds? You see, the circuit is connected at a particular time, right? No problem. After 5 seconds, that is instant, at 5 seconds, what is the current flowing in the resistor? That is the value I need to find. And everybody knows by Ohm's law, everybody knows what is the formula to find current. I is equal to V by R. That is not an issue now. Right. Now I need to find what is current at 5 seconds, right? I am writing the formula here. V at 5 seconds divided by R. That's all. This is the formula. And now my question is coming here. Exactly. Right. Again, I want to ask another question. Right. I have written the formula. You see here, to find what is current at 5 seconds, I have written the formula as voltage at 5 seconds. This divided by R, this is constant, no problem. I am not going to do anything with this constant value. This is resistance, no problem. But I have written V at 5 seconds. My question, what happens to the voltage before 5 seconds? Why I am not considering the voltage before 5 seconds to find the current at 5 seconds? So that is my question here. You see, now you come here. Now you understand the resistor in a way we know already, but I just want to enhance your knowledge. You see, the resistors are connected in an electrical network. So a voltage source is connected across this resistor now, the voltage source. It is taking energy from the voltage source. Whatever the energy it is taking from the voltage source will be dissipated into heat immediately, right? Whatever the energy it is getting at a particular time, a resistor will dissipate the energy into heat, energy into atmosphere by means of heat immediately. So the point you have to understand, resistors don't store energy, and the amount of energy it is dissipating into heat, that is totally related to what is the value of the resistor. I am not going very deep into those kind of things. Anyhow, the point you have to note here, whatever the energy it is getting from the voltage source, it immediately dissipates all the energy into atmosphere by means of heat. So a resistor don't store any energy. That is the point you have to understand. That is what we have written here. The resistors don't store energy. So now you come here to this point. So if I want to find what is current at 5 seconds, I don't need voltage before 5 seconds. Why? Because my resistor will not store any energy. It don't know what happens before that instant. Actually, if you want to understand resistors don't know what happens before that instant. You understand in a way, in that way. Fine. Now I will consolidate and I will write the formula for resistor in a general way, right? Generalizing the formula. I instantaneous will be equal to what? V instantaneous by R. So this is the generalized formula to find what is the instant current in the resistor. Fine. Now, what are all the points you need to note here? Very important, right? Note. First point, resistors are memory less elements. So you have to understand that resistors are memoryless elements. They don't store any energy. That is the first point you need to understand. Second point, to find instant value of current, we don't need past history of voltage. right? These 2 points are very important. Why I'm very keen to explain a resistor in this way, since inductors and capacitors are energy storing elements. I just want to compare, right? Because these three elements are related to each other. We are going to use all these three elements in an electrical network. So you compare one with the other so that you can easily get the knowledge, deeper knowledge about resistors, inductors and capacitors, right? So these two, inductors and capacitors, are energy storing elements. You can't find what is instant current or voltages in inductor and capacitor with only instant voltages and currents. No, not possible at all. That we will see in the next class, right? So I will give you all the documents, that is whatever we are teaching here in the description. You can download all the documents from the description, from the link given in the description. Thank you.